Welcome to the third video in the Digital Literacy Professional Learning video series hosted by Science East. In this video, we're going to talk about how to incorporate digital literacy into your math curriculum. First, let's take a step back and talk again about what computational thinking is. Now, in the introduction, I said that computational thinking is taking one large goal and breaking it down into smaller steps. And I had used making a sandwich as an example. Let's go through another example. If I want to raise my hand in class like this, let's think about all the different components that I have to go through in order to have my hand go up. First, something has to cause my hand to want to go up. I need to have a question. I need to have something to say. Maybe I need to ask to go to the bathroom. So something has to cause this to happen. Second, my shoulder has to rotate. My hand has to be in just a normal, relaxed shape instead of a fist. And my elbow first bends. My hand comes up. It keeps coming up, it's raised a little bit more, my shoulder starts rotating, it keeps going up. And then there has to be a point at which my hand doesn't need to go any higher. So is it when it gets past my head? Is it when it gets straight up and down? Is it when my elbow's at a certain angle? So if we were to program a robot to raise their hand, we would have to think about all of those steps in sequence and in what detail. The same process applies to digital art and media projects. We might have a vision in our head of what we want it to look like, but we have to think about what technology to use in what sequence and how to use it in order to make that vision happen. It also happens the same in coding. If I was to make a program to have my sprite raise their hand, I would have to go through the same amount of steps and the reason and the limitation of it in order to have it happen on the screen the way I am envisioning. So you might be asking, how does this fit into math? Well, computational thinking is all about problem solving, patterns, and sequences. Have you seen those words in your curriculum before? I can almost guarantee that you have. And so you can use computational thinking and therefore technology in order to meet these outcomes in your math curriculum the same way that you would use traditional math problems. You can do this because traditional math problems is also computational thinking. For example, if you have a word problem that says Rebecca has 7 apples, she gave 1 apple to each of her 3 friends. How many apples does she have left? Well, you have to think through that problem. What do you need to do first? What answer are you looking for? What do the numbers mean? What do they represent? So first, I would have to decide how many apples I gave away. 1 to each of my 3 friends, so 3 apples. Then how many did I start with? 7. So 7. Then I have to decide what operation, which is subtraction. 7 take away 3 equals 4. And then what does that number represent? And how do I tell people that that's my answer? So now I'm going to show you 2 examples of using computational thinking in your math class. The first one is meant for the younger grades, and the second one is meant for the older grades. So let's go see how you can use BeeBots in your younger grades to teach computational thinking. Okay, so this is Kaylee, and she has never used the BeeBots before. So we're going to show you how to do this activity with your classroom, usually about pre-K to 2, by showing Kaylee how to do it. So this is our BeeBot, and on the top it has a stop button, a pause button, your directional arrows, and your go in the middle. And we've set up a grid of honeycombs right here, and we've put flowers as your end goal. So Kaylee, you're going to use the BeeBot, it's already turned on, to get from here to your flowers.
Okay. So I'm going to press the button to correspond to each.
Yes,
choose my path.
Yes, you need to plan your path there.
So forward once, twice, turn to his left. Forward once, twice. Is that left again? Left. And then straight.
Okay, now let's press go and see how close you got.
Oh no!
Well, we got to the flowers, but it's continuing on. Okay, so what Kaylee just did there was that when she pressed turn, she expected it to go like this. But, like we had talked about computational thinking, you actually have to break that big step of turning down into 2. So to get from here to here, you actually need to go straight, turn, and go forward. So, you want to try again?
Yeah.
Okay.
Okay. I want it to take the longer way. Do it. No, I'll just, okay, so
chose one of the shorter paths, but I don't think it was the shortest. Do you, Kaylee? Is there a shorter path that you think you can find?
Yes.
You want to try one more time?
Yes.
There we go. So not only did Kaylee use computational thinking to break apart the large steps of turning, but she was also using her problem solving skills to figure out how to get to the flower and then the shortest path to the flower. Okay. Now I want to show you how to use pocket labs in your upper year classes to teach computational thinking in math. So in this activity, we've attached a pocket lab to a Hot Wheels car and created a track. This is a simplified version of an experiment that your students could create to measure different things. In this case, we're measuring acceleration. They can see the data in real time on the tablet. In this example activity, we can see my coworker Chloe holding a pocket lab in her hand and completing jumping jacks. Her data is being recorded in real time. You can see that on the graph that it's recording all three axes, X, Y, and Z. So in those two Pocket Lab activities, they were really simplified visualizations of how a Pocket Lab works and what sort of data you can create from it. The rest is up to you and your students. What topic are you working on? What interests your students? How can you make this fit in cross-curricularly? So in summary, computational thinking and therefore digital literacy is math. You can use digital literacy to meet your math outcomes, and you can often do it cross-curricularly.